welcome back. So in the past couple of videos, we studied some concepts related to counting, such as permutations, combinations, and so on. In this video, we shall take a look at some of the problems related to these concepts. So this is the first problem, right? So in how many ways can a committee be formed from 4 men and 6 women? So we have 4 men and 6 women to work with. In part 1, we want this committee to have at least 2 men and at least twice as many women as men, okay? So first of all, we shall see what are all the different possibilities here. So let me move this. So we have, let's see, 4 men and 6 women, right? 4 men and 6 women, and we want the committee to have at least 2 men. So of all the different possibilities, right? So let's see, we have to have 2 women and at least twice as many women as men, right? So if we have 2 men, then we need to have either 4 women, or we can have 2 men and 5 women, or we can have 2 men and 6 women, right? The other possibility is, so remember it was at least 2 men, right? So it's possible that we have 3 men. So let me write it here. So it's possible that we have 3 men. If we have 3 men, then we have to have at least twice as many women. That's 6 women, right? So let's see. So there are no more women, right? So we have total 6 women. So we are done with all of the women. So can we have 4 men on the committee? So if we have 4 men on the committee, then we have to have 8 women, but this is not possible, right? So we have exhausted all of the possibilities. So we can have either 2 men 4 women, or 2 men and 5 women, or 2 men and 6 women, or 3 men and 6 women. So this exhausts all of the conditions. So in how many ways can we choose, right? So let's see in how many ways we can pick this committee, right? So we have to choose 2 men out of 4 men. So that's 4 choose 2. And so multiplication, this is the multiplication rule. And we have to pick 4 women out of 6. So 6 choose 4, right? So we are choosing, in the committee, we are choosing men and women. Order doesn't matter. So we're looking at combinations here, okay? Plus 2 men. So that's 4 choose 2 and 5 women out of 6. So 6 choose 5. Again, 2 men out of 4. So 4 choose 2. 6 women out of 6. 6 choose 6. 3 men out of 4, 4 choose 3, and 6 women out of 6. So these are all of the possible committees that can be formed in condition 1 or in part 1, okay? So let's see. So let me minimize this. And yeah. So you see this. So I have typed out the answer for you, right? So this is, yeah, that seems to be correct. So that's part 1. So I have typed it here for you. However, now you know where this answer comes from, okay? So let me clear my screen and let's move on to the next one. So the next one is a little bit more complicated. So what do we have in the next one? So we need to choose 4 members. So in this committee now, we are limiting this committee to 4 members. And out of these 4 members, at least 2 of them have to be women. And in this set of people, we have Mr. and Mrs. Schmidt. And in this committee, Mr. and Mrs. Schmidt will not serve together. So in how many ways can a committee be formed from 4 men and 6 women, right? So this committee has to have 4 members. Out of these 4 members, at least 2 have to be women, and Mr. and Mrs. Schmidt will not serve together. All right. Let's see. Right. So at least 2 women, So let's start by writing out all of the possibilities. So this is a possibility. So we can have a committee of 2 women. So it has to have at least 2 women. And remember the total, in total, we have to have 4 members, right? So maybe I'll just shift this a little bit. Okay. So 2 women, and then we have to have 2 men, right? If the committee has 2 women, then the remaining 2 members, or we have to have remaining 2 members, and these 2 members will be men. Another possibility is we have 3 women and 1 man, right? Because the only condition is that at least 2 have to be women, right? So we can have 3 women, or we can even have 4 women, right? 4 women, and which means that we are not choosing any man, so that's 0 man. Okay. All right, so let's see what's happening in this first committee. So let me write this here. We have this committee of 2 women and 2 men. So we have this thing about Mr. and Mrs. Schmidt, right? So they will not serve together. So what are all the possibilities? So we have 2 possibilities here, right? So in this committee, we're choosing 2 women, and suppose one of them is Mrs. Schmidt, right? So it contains Mrs. Schmidt, Schmidt, and we have another possibility that this committee does not contain Mrs. S. Okay. So let's see. So there are 2 possibilities. So if this committee contains Mrs. Schmidt, so we're choosing 2 women. Out of these 2 women, one of them is Mrs. Schmidt. So we're essentially choosing one woman, right? So we had 6 women in total. Out of them, 1 is Mrs. Schmidt, who's picked. So now we have left 5 women, right, left, and we're picking 1 woman out of 5. That's 5, choose 1. And let's see. And then we are picking, so if this contains Mrs. Schmidt, so remember that Mr. Schmidt will not be included, right? So we had 4 men, but now we have to exclude Mr. Schmidt from this list of 4 men. So now we have only 3 men to choose from, and we are choosing 2 men out of 3. So that's 3, choose 2. So let's see the other, on the other branch, right? So it does not contain Mrs. Schmidt. So we had 6 women. So now we're picking 2 women out of 5, right? Because we're removing Mrs. Schmidt. So that's 5, choose 2. And now this doesn't contain we are not picking Mrs. Schmidt. So we are free to pick Mr. Schmidt here, right? So now we are choosing 2 men out of 4. So that's 4, choose 2, right? So for this particular possibility, we have all of these combinations, right? This plus this. So remember, we are multiplying these 2, right? I haven't written the multiplication sign. It's the multiplicative rule. We are multiplying these 2 numbers. So let's see. So now if I look at this possibility, the 3 women and 1 man, again, I have these 2 possibilities, that it contains Mrs. S and does not contain Mrs. S, right? So now if it contains Mrs. S, so Mrs. Schmidt, so now we have 3 women, 1 woman is fixed, right? So now out of 5 remaining women, we are choosing 2, and we have 1 man, right? Now we cannot choose Mr. Schmidt now. So we have 3 men, out of which we are choosing 1. And let's look at the other possibility. I should put this up. So the other possibility is that it does not contain Mrs. Schmidt. So we are picking 3 women, but now we have only 5 women to choose from, right? Because we're excluding Mrs. Schmidt. Now in men, we are free to include Mr. Schmidt. So we have 4, choose 1 possibilities, okay? And for 4 women and 0 men, we don't, so since we're not including a man, we don't have to account, we don't care whether the group of women here contains Mrs. Schmidt or not, right? Because there is no man here. And the way to choose to choose 4 women and 0 men out of 6 women and 4 men is basically 6 choose 4, right? We're not choosing a man, we're choosing 4 women out of 6, and we are choosing this is out of 4 choose 0, this is 1, right? 4 choose 0 is going to be 1 in any case. So these are all of the possibilities and we need to add them up, right? So final answer is going to be, let's see, it's going to be 5 choose 1 times 3 choose 2 plus 5 choose 2 times 4 choose 2, right? That is this particular combination, plus 5 choose 1 times 3 choose 1 plus 5 choose 3 times 4 choose 1 plus 6 choose 4 times 4 choose 0. Okay. All right. How do you simplify this? So 5 choose 1 is 5 factorial divided by 4 factorial times 1 factorial. So I'm not going to write 1 factorial because 1 factorial is 1. Okay. Times 3 choose 2, that's 3 factorial times 2 factorial times 1 factorial, but I'll again not write that. That's 5 factorial, 2 factorial, 3 factorial times 4 choose 2 is 4 factorial, 2 factorial times 2 factorial. Then we have 5 choose 2 again, that's 5 factorial, 3 factorial, 2 factorial times 3 factorial, 2 factorial plus 5 factorial, 3 factorial, 2 factorial times 4 factorial, 3 factorial plus 2 factorial, and we have 4 factorial. Okay, so this is just so if you remember, n choose r is n factorial divided by r factorial n minus r factorial, right? This is the formula that I'm using. So in any case, I can see that this eraser is not updating. Anyway, so 5 factorial divided by 4 factorial, so that's basically, so let's see, 5 factorial so 5 factorial divided by 4 factorial is going to be 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. So this will cancel out. So only 5 will be left here, right? So I will, so 5 factorial divided by 4 factorial. You can also think of this as 5 times 4 factorial divided by 4 factorial, and you're left with just 5. Okay. So let's see. So this is 5 times 3 factorial by 2 factorial is going to be 3 plus 5 factorial, the second term, you'll be left with 5 times 4. The 3 factorial will cancel out. I have 2 factorial, which is just 2 basically. So I'll let this be. Times 4 times 3 divided by 2 plus 5 times 4. 3 factorial cancels out, 2 remains. Then 3 factorial, that's 3 plus 5 times 4 divided by 2 factorial times 4 plus 6 times 5 divided by 2. And this is going to be 15 plus 2 cancels out, 5 4s are 20, 3s are 60, plus this cancels out, and then I have 30 plus 2 2s are 4, 5 2s are 10, and then we get 40 plus 15, and this turns out to be 160. So this is the answer. Okay. So in the exam, I may not always require you to like do all of these simplifications for a lot of problems, right? So I mean, I just did this for demonstration. It is enough to leave the answer at this first part. Okay, it is enough to write just this expression: 5 choose 1, 3 choose 2, 5 choose 2, and so on and so forth. Okay, so you don't need to do this simplification unless I ask for it specifically. All right, so this is one way to do the problem. Let's see another shorter way to solve this problem. All right, so let's see another way of solving the same problem. The second problem, the second way is probably a little bit shorter, but I just want you to show you guys different ways of approaching these problems, okay? So in the second way of solving this part 2, we're going to consider N1. So N1 is a number of 4 committees, right? At least 2 of which are men, at least 2 of which are women. So N1 is basically all of these 4-member committees, at least 2 of which are women. So we don't care about Mr. and Mrs. Schmidt, okay? And then N2 is all the number of 4-member committees in which contain at least 2 members and in which Mr. and Mrs. Schmidt do serve together, okay? So N1 is just 4 members with 2 women, and N2 is 4-member committees with 2 women and in which Mr. and Mrs. Schmidt will be together. So basically, the solution that we're looking for, it will then be N1 minus N2, okay? So N1 minus N2 is what is the solution. So let's see, how do we calculate N1, right? So let's see. So N1, all we care about that we have 4 people and at least 2 women. So we can have 2 women, 2 men, 2 women, 3 women, 1 man, 4 women, and 0 man. So 2 women, so it's basically 6 choose 2. Then we have 4 men, 4 choose 2, right? Plus, this is 3 women, so 6 choose 3, 4 choose 1, 6 choose 4, and this is just 1, right? So 0 man, so that's 4 choose 0, this is just 1. So that's N1. N2, so in N2, we have 4 members, 2 women, and Mr. and Mrs. Schmidt. It's decided that they are going to serve together. So let's see. So in N2, so basically in N2, Mr. and Mrs. Schmidt are both included. So again, we have these possibilities, right? So we have 2 women, 2 men, total in the committee 3 women, 1 man. But now 0 man, right? Like you heard, the 0 man, we had this possibility. We do not have that option again because we're including Mr. Schmidt, right? So these are the 2 possibilities. So out of 2 women, we know that one of them is Mrs. Schmidt. So we are choosing basically 1 woman out of 5. And out of these 2 men, 1 man is Mr. Schmidt. So we're picking only 1 man. So we're choosing, no, not 4. We're choosing 1 man out of 3. And here, We have one man, which is Mr. Schmidt, so that's fixed. 3 women, we're picking 3 women, out of which we know that one is Mr. Schmidt, so that's 5, choose 2. So these are all of the possibilities. So you see, this is what we have here. And the final solution is then n1 minus n2. Oops. Right? And if you solve for this and you simplify all of this, and you'll verify that we get the same number of possibilities, which is 160. Okay, so I will not simplify this because I already did it for the previous way of solving. But do go ahead. It's a good practice to do this at least a couple of times. You get a hang of how to work with combinations. So you should get the same answer here, right? That's 160. So that's the first problem. So now let's move on to the second one. So in the second one, so in how many ways can in how many ways can 8 people be seated in a row if A, there are no restrictions on the seating arrangement, right? So there are no restrictions on the seating arrangement. So that's basically looking at rearrangements of 8 people out of 8 people. That is 8p8. So let's see. For part A, right, we are seating 8 people beside each other. So now since we are seating people, we are rearranging people. That's another way of looking at it. Order matters, right? So what we're looking is we have 8 people, and we're looking all possible sequences of rearrangements of 8 people. That's 8p8. If you remember, that's 8 factorial divided by 0 factorial, which is 8 factorial. Okay. Another way to approach this, or an equivalent way, is 1, 2, 3, 4, 5, 6, 7, 8. We have 8 people. For the first person, I have 8 possibilities, right? Because I have 8 people. For the second spot, I have picked my person in the first spot. So I have 7 possibilities. In the third spot, I have 6 possibilities, and so on, right? So you get the same thing. 8 factorial is 8, 7, 6, 5, 4, 3, 2, 1. For the last spot, you have only one person to choose from, right? Because you've allocated all other 7 people to the other 7 spots. So let's see part B. Person A and B must sit next to each other. Okay, so person A and B will sit next to each other. So let's see, how does this look like? So we have 8 people. 1, 2, 3, 4, 5, 6, 7, 8. Not 8 people, 8 spots. These dashes stand for spots. Okay. So I have person A and person B. Suppose I fix them to, suppose they're sitting in these first 2 spots, right? So I'll put a circle around this to indicate that, they're kind of stuck together. So A and B, and so then I'm left with 6 people, right? That I can fill in these 6 other spots with. So that is 6 factorial, right? 6 people I can rearrange in 6 possible ways. And now I have AB, right? I can flip them around, right? AB, I can permute them, or I can rearrange them. So that's 2 times, right? So AB and BA are 2 possibilities. So times 2, okay? But this is all of the permutations when A and B are fixed in these 2 spots. Why should they be in these 2 spots, right? This is another possibility. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 spots. AB are here. This is AB are in these 2 spots, right? So again, I have all of these empty spaces I can fill with 6 people in 6 factorial ways. I can shift around AB, right? That will give me a different combination. So I can keep doing this, right? So AB, 1, 2, 3, 4, 5, 6, 7, 8. In the first position, in the first case here, AB had the first 2 spots, the second 2 spots. In the third one, AB can be here. This is one possibility. Or it can be here, or here, or here, or here. So how many such possibilities do I have, right? So 1, 2, maybe I'll count this again. 1, 2, 3, 4, 5, 6, 7, 8. So let me see all these positions where I can put AB together, right? This is one position, 2, 3, 4, 5, 6, 7, right? There are 7 ways in which I can place AB together. And for each of these 7 ways, right, I can either, right, there are 7 ways in which I can place AB together. For each of the 7 ways, I can permute AB, right? So I get 2 combinations for those. And then for the remaining 6 people, I can arrange them in 6 factorial ways. So this is the final answer. You can rewrite this as 2 times 7 factorial, right? Because 6 factorial times 7 is just 7 factorial. So this is the answer. So I've given the answer here. Okay, I've calculated the number, but yeah, the important thing is doing this calculation. So let's see. In part C, so we have 8 people, out of which 4 are men and 4 are women, and no 2 men or no 2 women can sit next to each other. Okay, we have 4 men, 4 women, and no 2 men or women can sit next to each other. All right, so again, we have 8 positions, right? So 1, 2, 3, 4, 5, 6, 7, 8. And we have 4 men and 4 women, and no man and no woman is going to sit beside each other. So suppose the first position goes to man. So then that means the next one we have to have a woman, man, woman, man, woman, man, woman, right? These are the possibilities. So for this case, right, so I am allowed to shift my men, right? So this is man 1, man 2, man 3, man 4, right? So nothing is stopping me from rearranging all of these men amongst each other, right? So I can flip 1 and 2 man, or I can flip positions of the second and the third man, and so on and so forth. So I get 4 factorial combinations, right? So I have 4 people and I rearrange 4 people. That's 4p4, that's 4 factorial. And I can do the same with the women, right? So every time I shift a woman or I interchange positions of women, I get a different permutation, right? So that's 4 factorial. In this sequence, I started with a man, but there is no reason to do that. So 1, 2, 3, 4, 5, 6, 7, 8. I can easily start with a woman, right? And still satisfy the required conditions given in the problem. So woman, man, woman, man, woman, man, woman, man. Now I get different permutations or different rearrangements when I shift all of the women amongst each other, right? Remember, if I shift all of the women, the conditions are still satisfied, right? Like women's are still in these alternate positions, but I can swap this woman 1 and woman 2, for example. So that's again 4 factorial, and I can do the same with the men. That's 4 factorial. So you add these two, so the total number of such permutations are 2 times 4 factorial times 4 factorial. Okay, so that's part C. Part D, there are 5 men and they must sit next to each other. So again, 1, 2, 3, 4, 5, 6, 7, 8. Now there are 5 men and they have to sit beside each other. So this is one possibility. 1, 2, 3, 4, 5. So I have all of these men sitting here. And All of the women obviously go in these last three positions. So again, I can shuffle the men amongst themselves, right? So that's, I can rearrange 5 men, that's 5p5, that's 5 factorial. And I can do the same with the women, that's 3 factorial. But again, who's to say that the men must take the first 5 positions, right? They can take the second 5 positions. So 1, 2, 3, 4, 5, 6, 7, 8. That is, all of the men are from position 2. That's 1, 2, 3, 4, 5. So all of them are here. So again, we can shuffle them amongst themselves and all of the women amongst themselves. Then we have another possibility. The men can start sitting from the third position, right? So 1, 2, 3, 4, 5, 6, 7, 8. So I think 1, 2, 3, 4, 5. Yep. And finally, 3, 4, 5, 6, 7, 8. We can have all of the men starting from the fourth position, right? Right? So these are all of the possibilities, okay? So I have 1, 2, 3, 4. I have 4 possibilities of where all the group of men can sit. Then for each possibility, I can shuffle the men. That's 5 factorial. In 5 factorial ways, I can shuffle all the women to get 3 factorial possibilities. So this is the final answer. You can write this as 5 factorial times 4 factorial, right? Because 4 times 3 factorial is just 4 factorial. So for part D, this is the answer, 5 factorial times 4 factorial. So now let's see what happens in part E. In part E, there are 4 married couples and all of them have to sit beside each other. All right, so 1, 2, 3, 4, 5, 6, 7, 8. So this is the married couple, another one, another one, another one. This is couple 1, couple 2, couple 3, couple 4. So this is the order of the couples, right? So couple 1 is first, couple 2 is second, 3 is third, couple 4 is fourth. Then I can shift people, right? So I can suppose this is the man and this is the woman. I can permute the woman and the man, or maybe I should say partner 1, partner 2 instead of man or woman. But you get my point. So I have 2 people here. I can permute them, right? Or I can rearrange them to get 2 factorial possibilities or 2 possibilities. Same thing with the second couple, that's 2 factorial. Same thing with the third one, 2 factorial. Same thing here. So which is basically 2 raised to 4, right? So for each sequence of these couples, we have 2 raised to 4 possibilities. But now I can rearrange the order of the couples, right? So I can, for example, have C2 couple first, C1, C3, and C4. Right? So I can basically rearrange the sequence of couples, right? So I have, this is, so if I just call this as the first couple, second couple, third couple, and fourth couple, so these 4 couples can be rearranged in 4 factorial ways, right? So 4 couples can be rearranged in 4 factorial ways. Within each couple, you can shift the people involved in each couple to get 2 raised to 4, right? So for each such combination, we have 2 raised to 4 possibilities. So this is the total number of rearrangements. That's 4 factorial times 2 raised to 4. 4 factorial is number of rearrangements of the couples, and 2 raised to 4 is the number of rearrangements within each couple permutation, right? So this is one couple this is a single permutation or single arrangement of the couples, and within this arrangement we have 2 raised to 4 possibilities. So multiplication rule, 4 factorial, okay, maybe this I should write this 4 factorial times 2 raised to 4. So in this question, we'll see in how many ways can 3 novels, 2 mathematics books, and 1 chemistry book can be arranged on a bookshelf if A, the mathematics books must be together and the novels must be together. So let's see. We have 3 novels, 2 mathematics book, and 1 chemistry book, is that right? And 1 chemistry book. The mathematics and the novels have to be together, okay? So all the mathematics books and the novels have to be together. So we basically have 3 groups, right? We have a group of novels, a group of mathematics books, and a group of chemistry book. It has just 1 book, but it's still a group. So we want the novel and the mathematics to be together, okay? And so 1, 2, 3, 4, 5, 6. So I have total 6 books. So I can have all my novels together, all of the mathematics, and this is my 3rd group of chemistry. So I can also view this instead of positions, right? I can think of this as this is group 1, group 2, group 3. So whenever you have problems where you're grouping bunch of objects together, it might be easier to think of these as groups, okay? So now I have, right? So this is one possibility. I have first the 3 novels, then I have followed by the math books, followed by the chemistry books. Now for this arrangement of the groups, right? You can also extend this thinking of groups to the previous problems, right? You can think each couple is like a group, right? In any case, so I have 3 groups, and I can permute or I can rearrange all of the novels within this arrangement. So I get 3 factorial, then all the mathematics books. So that's 2 factorial times 1. So that's 3 factorial, 2 factorial, okay? But who's to say that I need to have the novels together, right? I can have mathematics books first, right? So I can have math books, then I can have my novel. Maybe I should call this as 1, 2, and 3. And this chemistry book, right? So I have these 3 groups, and I can permute these 3 groups, right? So you can consider a group as a single object. So you have 3 objects, and you can rearrange those 3 objects in 3 factorial ways. So we have 3 factorial ways in which we can arrange the groups. Within each arrangement of the group, we can shuffle all of the novels to get basically this, right? 3 factorial arrangements, and all of the mathematics books to get 2 factorial arrangements. So this is the final answer, okay? Let me just maybe elaborate on this further, right? So this was the second group, and here again I can permute the math to get 2 factorial, 3 factorial, and the third possibility is I can have chemistry, I can have N1, N2, N3, I can have M1, M2, right? I have all of these possibilities, and for each of these I have 2 factorial times 3 factorials, right? So the total number of permutations, I'm going to add all of these up, but I have 3 groups. So therefore I can arrange them in 3 factorial different ways, right? That's 3 factorial possibilities. It's too painful to list out all of these combinations, right? So you can have novels followed by mathematics, followed by chemistry, mathematics, novel, chemistry, chemistry, novel, mathematics. You can have mathematics, chemistry, novel, and so on and so forth. So that's 3 factorial combinations, and for each of them I have 2 factorial times 3 factorial arrangements. So that's 3 factorial, 2 factorial, 3 factorial, okay? So again, we have 3 groups. For each group, I have 3 factorial times 2 factorial arrangements, right? And for each of these groups can be arranged in 3 factorial ways, and multiplicative rule gives you this. So in part B, the novels must be together, but the other books can be arranged in any order, right? So we have 6 books, out of which 3 are novel, and these 3 novels have to be together. So yeah, so 1 2 3 4 5 6, I have these 6 places for 6 books. 3 novels have to be together. Suppose they are here. So, and these 3 books can be arranged in 3 factorial ways. The 3 novels can be rearranged in 3 factorial ways. So who's to say that the first 3 books have to be novels, right? The second 3 books can be novels as well. So 1 2 3 4 5 6 novels can take this position, either the first 3 positions, or the second 3 positions, or the third 3 positions, or the fourth 3 positions. So there are 4 ways in which you can have these 3 novels together, right? And then for each of these possibilities, you can permute the novels to have 3 factorial rearrangements, and you can move around the other books to have 3 factorial arrangements. So you can rewrite this as 4 factorial times 3 factorial. So you see 4 factorial times 3 factorial. So that is all for this video. Do try to solve this on your own, right? Like once you watch this video, go ahead and try to think about this on your own. It is very important that you're able to visualize what is going on, right? Everyone has their own ways of doing it. It might be different from mine, but you should be able to understand and deconstruct what is going on in these problems, right? You have to visualize these problems. So you have to break them up, right? Like I'm breaking up all of the possibilities. You have to be able to do that to solve these problems. So it takes some time. These are not easy, okay? Yeah, so just give it some time and practice, and most importantly, think about it. Yeah, I'll see you in the next video. Bye.